All right, welcome to a weekend episode of the JNCIE-SP. Um, so yeah, I'm going to be really hitting the gas pedal for the next month because I'm going to be taking my test in about a month. I'm not quite ready to register because I think I'll be taking it on like the 11th or something. So tomorrow I can register, but you're not supposed to register more than 30 days out. So I haven't registered yet, but I will be registering very likely by the end of next week. So I got a comment on my channel from Caillou. Yes, I can make my JNCIE-SP folder public. So what I did is I moved it over to my actual channel email out of my private folder, and then I did a get link on it. So now there's a public link. Anyone with that link can view the contents. But at this point, I don't see a reason to give editing permissions. But so I'm going to start off the video today by responding. Okay. Yes, here is the folder with view permissions. Okay, so yes, here is a link to the folder with view permissions. So yeah, that might be useful for you because I have gathered all of the documentation I used in there. So if you want to know what I used or anything like that, you can find it in there. Really, I don't think there's anything too groundbreaking in here. I mean, everything here is just the curriculum. If you just go to JNCIE-SP, oops, gotta spell it right though. JNCIE-SP. All the folder names, everything like that is just the curriculum here. So, and then it's the 961 version of the exam. So it's not like I just made up my own topics to go through. They're all here. And then all of the documentation inside of it is just links to official Juniper documentation, so stuff you should be able to find. There's really nothing too interesting in there, in my opinion, but I can definitely make that public. There's really nothing in there that I would want to be private. Maybe the notes. Oh yeah, I found some free like workbooks online too. You can see that it's marked with a demo only watermark on it. Yeah, demo version watermark. So I found that so this stuff actually might be pretty useful, but it's all like really out of date, and it's all so yeah, I don't know. Maybe there's some more useful stuff in this notes folder, but yeah. But the stuff in the notes folder I haven't really been focusing on as part of these videos. So I guess I'm not sure how useful the stuff in that folder would actually be, especially since I'm not focusing on it. Okay, but these are now in my Grams Network lessons drive, so I won't be updating the other drive anymore. I'll be updating this one. So I'm gonna open it in Google Docs. there you go. And yep, I'm gonna do a weekend video. I've got something I've got to do at 3, so this will just be a half-hour video, hopefully getting the lab configured and ready to go. Okay, so yep, time to pull up the lab. Okay, so now I'm going to finish configuring everything. So I believe I stopped here last time, so I'm going to start with router K. It's going to be quite similar to router D, but it's got a lot of extra configuration and it's also got mistakes in it, so I figured I'd just leave it for today. Because I remember thinking in my last video that I could just rush through another router, but this is going to be too complicated to just rush through. Okay, so now it's time for the configuration here. So like always, they've got a mistake where they're adding a interface to the default instance that's meant to be applied to a custom routing instance. So I'm able to figure that out. Another interesting thing I'm noticing here is they've got traffic engineering enabled under MPLS. I'm not sure if they have it on the other router as well. Okay, so that's enabled. Now the interface I'm going to need to add is the one facing the internal network to this ISP, which is kind of a funny statement because they're both facing the internal network to the ISP, especially if you're imagining this as just a straight wire. But this is more true to that statement, so it's going to be this one right here that gets added. And I believe that's going to be, yep, that's going to be 000. Okay, so time to configure protocols with BGP. Okay, so the local address is going to be a 172 address. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, and then a neighbor, I'm not sure about that, so I'll look it up. Okay, so it's going to be router I. Let's take a look at which that is. Ah, it's this one here. So 1, 2, I think there's 12 routers, so router I is going to be .11. Oops, and I forgot to enable the NLRI, network layer reachability information, that I would like this BGP neighborship to process. It's going to be iNet labeled unicast. Okay. All right, so here we've got, oh, that's because this is the eBGP connection to router H, so it's going to be the port on the interface. That's something they haven't provided, is the interface ports, but we can count it up. 1, 2, 3, 4, 5, 6, 7, so it's going to be 8.1. Perfect. Okay, time for OSPF. Okay, and this is going to be the internal facing interface. Perfect. Okay, so everything pretty much ready to go. There are some things I am missing. One of the things I'm missing is enabling family iNet on the interfaces. So let's add that. I believe that's the only thing I am missing. There might be something else. It's not going to be family iNet, it's going to be family MPLS. Okay, so that looks good. Let's move on to router L, and we'll go back through, do one final show configuration on all the routers, make sure I didn't miss anything. But next is going to be, oops, so it looks like I forgot to define the local autonomous system. Let's look at the topology, and let's take a screenshot of the topology so it's easier to go back and look at it. Okay, this is going to be AS21, and one thing you'll notice is that it's got the same AS number as up here. That's because this is the same autonomous system. It's the same ISP. So they're going to have the same AS number. Now, if you haven't watched the previous videos and you know a bit about BGP, one thing might immediately stand out to you, and that's going to be, how is this going to work? How is it going to learn this, learn routes if it's learned from AS21, then it passes through AS11123, and then it goes back to AS21, because that is the reason BGP keeps track of a list of your ASs is to check if there's an entry on the list that is the same as your own AS. So now the BGP is going to originate from here, so it won't be checking that list. But now when it arrives here in this AS, it will have 21 added to that list, 21. But when it comes over here, it's going to have 21, and then it's going to have 1123 added to that list. But it's going to see its own AS as 21, which is already in that list, so it wouldn't allow it to import. It wouldn't even show up in the table at all. So what can be done about that? Well, on these routers here, what happens is we enable a knob called AS override, and that makes it so that when it gets past here, instead of having the 21 listed in the list, it crosses it off, and all it does is has its own AS in that list. So when it arrives here, 21 is not already in that list, and the loop prevention mechanism is not triggered. Okay, but we do need to define the autonomous system here. And we can use 21 because we've got AS override enabled on the PE routers. And I believe there are other ways you can get around that besides just AS override. One thing you can do is you can allow a AS to show up in that list multiple times. I think it's AS-loop, or I forget what the command is exactly, but you can just say, hey, it's going to be in here more than once. Don't freak out. And you can specify how many times you want it to see it without it freaking out. So you can allow the traffic to loop if you want, and then it just can't loop more than 3 times or something like that. Okay, so yep, the commit was successful, so time to move on to router J. Okay, so router J is really nice and easy. Don't even need to enable MPLS, family MPLS on the interfaces because they're just going to be label them. I think I might be wrong about that, but we will find out shortly because I've only got 2 more routers to go. Okay, 2 more routers to go. So it moved on to router K, which is interesting. HIJK. It looks like I'm still on router I. Oh, you know what? It looks like I've got these mixed up. Oh. No, it looks like they got them mixed up. So they did, yeah, so router I acts as the PE router for the end customer. Oh, I see. So it looks like they skipped over. They did router H, but then instead of configuring the next router connected to H, they skipped over and they configured router I instead. So I'm not sure what the reasoning for that is, but it's not too hard to just move that configuration over. We might need to use different addressing though. So here's router H. Yep, so router I is the one we just finished, I thought. No, it's not. I don't know what I just did. Okay, so this is actually good news. It looks like what I did is I configured router K correctly. So somehow I was able to handle the fact that things were out of order. I think what I'm going to do is move on to router J next, or I'm going to do router L, then I'm going to do router J, and I'm going to save router K because that's the most complicated one. So next will be router L. And the problem here, this kind of sucks. There's actually no verification steps at all. So we're kind of on our own to verify the topology, but hopefully I'll be able to do that. Okay, and I'll need to see what the local autonomous system is. It's going to be 1. Okay. Okay, so this is going to be an EBGP neighbor to that first autonomous, or that first ISP, Internet Service Provider, that is renting a path over to itself. So this is going to be the IP address there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's 11. So 11.1 will be the neighbor. All right. All right, that's all there is to it. The CE routers are really nice and easy. Just as easy, pretty much, are the P routers, or the transit routers for MPLS that have, they're not the front and the back door to the house, they're just the living room where, yeah, so really nice and easy configuration left for router J, and then we'll get to the really difficult configuration when we configure router K next. Oh, so this is interesting. It looks like I actually already configured it. I thought I might, that's why I did a look at the active configuration, and it turns out that I did. Really good news. Let's move on. So, yep, I've got until 3, so definitely going to finish this by then. Do some verification steps, but I might want to do a whole nother video just to go into enough proper depth. So this is going to belong to AS21 as well. Okay. And then same deal like before. One of those interfaces there are actually going to belong to the custom routing instance used for the VPN. So we can't add it both to the default and the custom routing instance. So the only one that belongs in the default instance is the one that is facing internally. So this one here, 0. Now I might have flipped the other one when I did it for the PE router facing to the customer, which would be like a bank or something with multiple branches. Okay, so this is going to be, let's see here, so 11, or sorry, 12, 11, 10, 9. So I've got the addressing wrong, but I'll go back and fix that after I've finished with this. Okay, and I need to see what the neighbor is. Oops, so this I actually know. It's going to be here, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8.1, so of course the neighborship for the other router is going to be wrong as well, but I can go back and fix that later. Family iNet labeled unicast. Let's take a look at the help for that. Include labeled unicast NLRI. Then we're going to also include resolve VPN knob. So we're going to include the NLRI in the inet.3 table. Okay. So we've got one more neighbor. So set neighbor. Let's figure out. Okay, so this one is going to be, I believe, I think so my guess is that this one is going to here. So our neighborships, we're going to have these routers here peer together. We're also going to have them peer with these, and then these are going to peer EBGP. Of course, this is going to peer EBGP as well, just across the wire. These are going to peer together, EBGP, so that's what my guess is. Let's see if I'm correct. So local is router B. So this is router K is going to be a peer with router B. I'm actually kind of surprised by that. That's not what I was expecting. Oh, and it looks like I got it wrong somehow. Yeah, somehow I got mixed up so that I was configuring the wrong router. Right, because it's going in a strange order. Okay, I'm getting mixed up. Let's take a look at router K. So we're on router K right now. Top, show pipe, compare. All right, let's do a show pipe display set relative. All right. Yeah, I mean this looks good to me. We've got 2 ISP red. Yep, looking good. Everything seems fine. So yeah, we just need. Okay, yeah, everything seems to be going okay. We've got the policy statement, everything on there. So you know what? I'm getting a little bit confused here, but I think I have everything correct. Let's do a show pipe compare. Okay, so I didn't have the neighbor statement on there. Yeah, I was missing this one. Let's see if I've got the other one. Okay, I'm missing the other one as well. Oh, no, I've got the group INT. Yeah, I've got group INT correct, but it looks like I'm using the wrong address for group INT. I'm using the address to 8.1. That's the correct address for the EBGP group. So this says export internal. That's a different thing than type internal. The name of the group is internal. The type of the, or sorry, the name of the export policy is internal. The type of the BGP group is external. So really confusing here. Definitely would not recommend ever using that sort of naming. Okay, so oh, you know what? It looks like I do have it correct. I added it incorrectly here. Okay, so commit and quit, there's nothing to commit. I think it's all good. So I'm going to do my final check of all the routers. Okay, so we'll start by checking. Let me just do a rollback 0. Okay. Okay, yeah, everything looks okay. So let's do a final check of everything. So we're going to start by checking router A. Okay, and we can even go further and make sure we've got the BGP neighborship up, all that sort of thing. This will be a check of the configuration bundled together with the verification steps, which I'm going to have to come up with on my own anyways. So might as well just start verifying things right now. Okay, yep, this is really simple, very stripped down config. Let's check the eBGP connection. So it looks like it is up. You can see up here has a time value, even though the outputs are really all jumbled up. You can get a cleaner output here. Oh, okay, well, never mind. It's in state idle. I was wrong. So, okay, well, let's check that I can ping across the wire. And I can't. I've got no route to host. Let's sort of do a show route. So it looks like the it got configured. Oh, you know what? It's because my forwarding planes are still messed up. God damn it. Yeah, okay. Well, I'll try to fix that. So to fix that, I'm gonna try deleting the forwarding plane here. Yes, permanently delete it, please. Okay, and sometimes the icon gets stuck, but that'll be fine. And then I'll create a new one. There we go. Okay, and then I'll cable it up, and hopefully that should do it. I mean, maybe the cabling I got wrong or something like that. I have no idea. Okay, so now I can right click and I can go send lower one layer, and then I can do a start, and hopefully that will come up. I'll do a show chassis FPC or some similar command to that. Why don't I just use the same command I used here and then do a refresh on that, and every 3 seconds we can see a new output, and then we'll have, well, let's just do every 1 second. I like having a lot of activity on the screen sometimes. Okay, so now there's more activity on the screen. Okay, I'm not sure what happened here. Oh, there we go. Yeah, so now we got a lot more activity on the screen. Every second we can see that the forwarding plane is having issues still. Hopefully that fixes things. Let's move on to router B and see and verify the configuration. Okay, so we've got protocols MPLS look good. We've got the family MPLS added, really key to do that. And then we've got BGP internal, with our local address and our neighbor, which is going to be a loopback address. Labeled unicast, yep, everything looks good. Then we're going to have another BGP neighbor, another internal neighbor, so loopback address. Yep, so as I mentioned before, we're going to have on router B, internal neighbor to router D, and then also an internal neighbor over to router I, which is .11. Okay, and then we've got OSPF. Looks good. Yep, everything looks good for that. LDP, yep. I believe this is the right, yep, this is the right interface. This is the internal facing interface. Okay, so now things get a bit trickier. It looks like they're out of order. Let's go down and do it in the order here. VRF, yep, the external facing interface, because it serves as the front door for the customer. So this is definitely going to be facing the customer. Route distinguisher looks good. Yep, import policies, BGP group. Now here we're using VPNA -0. But I don't think there's going to be an issue with that. And then we're using the interface address to peer with, as is best practice for eBGP peerings, unless of course you want a eBGP peering that has link failover capabilities, then you would peer to a loopback address, but you need to enable a special knob, I think multi-hop, in order to do that. But since we're using the directly connected interface on the neighboring router, we don't need a special knob. We can keep our configuration nice and simple. So here's a difference. I forgot the 6, but it's only local to this router where that group matters, so I don't think it's worth going and changing. Okay, so VPNA import policy from BGP and then from the community, which we have defined here. So here's our route targets. Okay, and then we gotta then accept, and then B, we can see we've got things out of order, and the reason for that, it looks like is I accidentally oh nope, so I did it right. We've got 4 statements for import, and then we've got in term A, we've got matching here, and then we've got accept, and then we've got another term to explicitly reject anything that doesn't match. Same thing for the export policy. Now, one thing I am noticing that is kind of unusual is that they do have a import and an export policy. I don't think you need both. I think you only need an export policy, but I am not at all sure about that. Okay, but this looks good. Let's make sure family MPLS is enabled. It is. Okay, so now we can move on to the next one. Oops, and we can see the forwarding plane is still having a lot of issues. And it looks like it's not even showing the command anymore, so let's stop it. Okay, so yep, it's still having a lot of issues. Really not sure what's going on with the forwarding plane. This has happened before. It might be because it's so strapped for CPU. Um, I've definitely seen this happen before, but it still sucks. Okay, so I'm gonna stop that and I'm gonna do a show chassis FPC. Oh, and now this is really unusual because we can see it actually is present now. Oh, yeah, so what happened, I guess I don't understand why there aren't any interfaces if there's a chassis right now. Like if it's showing show chassis FPC as present, um, why is it not working? I mean, I guess it says absent as well as present. Okay, now this one is showing as online instead of present, so that's probably a better state. Let's see if the GENs are up on this one. Nope, so but this one doesn't have the GENs either. Okay, well that's too bad. I was hoping I could verify the example and really look into this in more depth, but if the forwarding planes aren't loading, it might be because 12 routers is just too many. I think with a valid license, I did the math before and like the best I could do is like 8 theoretically, so 12 is definitely pushing that, unfortunately. So yeah, I just don't think I have the capability to run 12 routers. It's going to cost me more money than I'm willing to spend. Um, the testing fee is already a lot of money, and the server I'm using just for um, even running 4 routers comfortably costs a lot of money as well. Um, so yeah, so I don't think it's going to work to verify my stuff. I think I understand carrier of carriers pretty well. I've got that AS path, the AS override concept understood pretty well. Um, I guess I'd be curious to double check where it is necessary to enable traffic engineering under protocols MPLS. So it looks like they did it on router C, they did it on router D, and that's it. They just did it on router C and router D. They might have done it on router B as well. Nope, they didn't do it on router B either. So Looks like it just needs to be enabled under router C and router D, according to the lab documentation, which is often quite flawed. Alright, so I'm going to pause the video. I'll be back shortly. Okay, I'm back. I've only got a few more minutes left. I gotta drive somewhere to be somewhere at 3:15. So I'm almost tempted to say, you know, as much as I'd like to dive in and look at the traffic and get things up and working, it's just not going to be technically feasible. I just don't have the resources to run 12 routers, especially after my trial license expiration. So yeah, I'm almost tempted to just mark it as done, and then move on to the next one. Very anticlimactic. I apologize for that. Unable to really dive in deep and look at the outcome, but I did get under my fingers the configuration for a carrier of carriers. I saw an error message that can be associated with it if you don't enable the port for MPLS under the correct instance. If you try to do it under the default instance, you get a error message specifically calling out carrier of carriers. So that was interesting to see. So a lot of good things happened here, even though I unfortunately have hardware inadequacies. Okay, so yep, maybe I'll buy a sports car or something to overcome my hardware inadequacies. But until then, I'm gonna mark this as done, and the next video will be inter-provider VPN. So yep, again, I apologize for being unable to verify this because my forwarding planes aren't coming up, likely because I have too many routers running and not enough resources to run them. But I think I got enough out of this to move on. So thanks for watching, and I'll see you in the next video where I go over inter-provider VPN.